Here are two more examples of using integration by substitution. This one we're actually going to look at in a couple different ways. Let's just attack it how we've been. You have this inside function 3x cubed minus 4, and that's raised to the fourth. So you can't use the regular power rule on this unless you want to. I mean, you actually could multiply this out and multiply the x squared through. It's going to take a while, but it's doable. But it'll take a lot of time. So I'm going to let u be this inside function. U equals 3x cubed minus 4. Now, before you go any further on this, think about what the derivative of u is. So this is a little bit more complicated than the ones we've done before, but this part helps right here, thinking of what the derivative is. It's going to be 9x squared. And if you can see there's an x squared out here, that means that's going to work out. And if you don't see why, you'll see why as we go through it. That's an important step on u substitution. So, So now we know that this is going to work. And now I completely lost it. So, good for me. All right, here we go. So the next step here is your du. Your du here is the derivative of u, which is 9x squared times dx. Now here's where I'm going to give you two options on how to handle this. Option number one is what just kind of follow along just how we've been doing this. You substitute your u, 3x cubed minus 4 is u. See this x squared, you can leave it there. And then dx, according to this, if you divide by 9x squared, is du over 9x squared. So you can substitute this in for dx. And one thing you're going to notice is this. The x squareds will cancel, which is nice. The 1/9 is a constant. So you're left with this, and this is an integral that you can easily use the power rule on because it's u to the fourth du. So that turns out to be just u to the fifth times the reciprocal, which is 1 over 45 u to the fifth. And when we substitute u back in, it's 145 times 3x cubed minus 4 to the fifth plus c. And that's your answer. So that's pretty similar to what we were doing. The biggest difference was we had this x left over right here that turned out canceling out. Now, as I said, we were going to do this a couple of different ways because that's not the way I usually do these problems. As you get used to them, you can shortcut it a little bit. So I wanted to show you that right now because a lot of you will benefit from this. So we're down to this point where I said du is 9x squared dx. And I'm not going to do this like I did in the last one. I'll show you what I mean. Let's first plug u back in. So 3x cubed minus 4 is u. And now notice, look up to the problem. You have x squared dx. So you can, the shortcut to this is your x squared dx is what we need to take care of. And if you look at your du, here's x squared dx. That whole thing, x squared dx, equals du divided by 9. So I saved a little bit of this writing over here. It's going to turn out to be the same, but it's much, I guess, simpler or quicker. You don't have to do it that way. You can choose either way because you're going to see we get the same thing. 1/9 u to the fourth is times the integral of u to the fourth is 1/9 times u to the fifth times 1/5, which is 145 u to the fifth, which is so that's a slightly different way to do this problem. They both are legitimate ways. As I've said, as you practice these, you're probably going to prefer this way. So you may, at least I do, so you may want to practice that. So I want to do one more question on this video. It's a similar problem, except we have a u in the denominator. But we really already know how to deal with that, so this is not a big deal. I just want to have you see it being done. So we're taking the square root of 3x to the fourth minus 2 on the bottom. So we're going to let u be that inside function. And then we're going to have to figure out what du is, which is the derivative, which is going to be 12x cubed. You see this x cubed up top? That means that's going to work out nicely. So that's always something to think about. Right now, I know my u is going to work because I'm going to be left with a 12x cubed. So now, du is 12x cubed dx. Now you're going to make your substitutions. So the bottom we said was u. And we still have that square root. That never changes. See this dx and this x squared? Look at them together. X squared, or x cubed, times dx. X cubed times dx is exactly equal to du over 12. So that this green circle now is green. X cubed dx is exactly equal to du divided by 12. So now we're going to integrate. But remember, we can't integrate yet because you can't integrate 1 over u to the 1/2. We can only integrate u to the n. So we have to bring this u to the 1/2 up. This is just like your normal simple integration. You always have to do that. And now you use the power rule, the only rule we know. Add 1. Multiply by the reciprocal, which is multiplying by 2. So that's 1/6 times u to the 1/2. And u was 3x to the fourth minus 2 plus c. So this one I'm not going to leave B until I check. We're going to do it in Wolfram Alpha. I'm going to type in integrate my original function, which was x cubed over the square root of 3x to the fourth minus 2. So x cubed divided by the square root of the quantity 3x to the fourth minus 2, close my parentheses. So it did it. First thing I'm going to do is make sure I typed it in right. So compare this with this. It's the same. The answer, according to Wolfram Alpha, is 1/6 times the square root of 3x to the fourth minus 2 plus a constant, which is this. We're good. And those are two good examples.